All right, 6.4 today. We are talking about rational exponents. So when we talk about rational exponents, the word rational or a rational number is anything that can be written in fraction form. Okay? So when we talk about them, remember that I always have a base. And I'm going to use b for my base right now. And I have an exponent here. If I have a fractional exponent, that fractional exponent represents power over roots every time. So we're going to be able to simplify things with those rational exponents. The rational exponent, again, is power over root. So, for example, if I have 25 to the 1/2 power, what that means is that I have 25 to the first power inside a square root, which we can simplify to 5. Or if I have x to the 2/3 power, that means I have x to the power of 2 inside a cube root. That's what that means. Now, part of today is remembering some of your exponent rules. So before we keep going, let's just revisit some of our exponent rules very quickly, okay? All right, exponent rules. We have several. First of all, write that down. There we go. First exponent rule is if I have anything raised to the 0 power, that equals what? 1, thank you. Anything raised to the 0 power is 1. If I have x to the m times by x to the n, so my bases are the same, my rule says that I keep the base and I add my exponent. If I have a base with an exponent and then it's raised to an exponent, here we multiply our exponent. So this is x to the m times n. And the last one I want to remind you of or point out is if I have x to the m divided by x to the n, the rule says we keep the base and we subtract our exponents. Right? We remember all these wonderful rules, correct?
I don't think I was here. I do know.
Okay. All right, so we're going to jump right into example number 1. And remembering these rules along with the idea that a rational exponent is power over root is what we need in this section. We are going to simplify the expression. And this is going to cover your 10 through 18 for those of you that like to look back and have something to refer to. Let's say I have -2 to the 1/3 times -2 to the 1/3 times by -2 to the 4/3. So all my bases are the same, correct? They all have the same base. So I keep the base. I'm going to put that group together. And I add my exponents. 1/3 plus 1/3 plus 4/3. So it gives me my -2 to what power? If I add these together, I technically get 6/3, which Orion's right, is squared. So this just equals 4. Try another one from this section real quick. This is just simplifying, following some of your rules. All right. What if I had 7 to the 1/2 power times 21 to the 1/2 power? Those don't have the same basis. So I can't use exponent rules. So now I have to look to using my rational exponent for what it is. 7 to the 1/2 is actually the square root of 7 times 21 to the 1/2 is actually square root 21. Can I multiply them together the way they are now? I can. This is going to be the square root of 147. And then I can break that down into 49 times 3. And 49 is 7 and 7. So this actually equals 7 square root 3. All right, so if the bases are not the same, then you put them in radical form. And then we simplify. Any questions so far? How are we doing? Okay. Let's go to example number 2 then. Example number 2. This is going to work with 20 through 26. And it just says write in radical form. And maybe I give you y to the 5/7. So in radical form, very good. We have y to the 5th inside a 7th root. Exactly. All right, what if I had, how about this one? What if I gave you t to the -2/3? Well, I guess that's one of the rules we didn't go over, a negative exponent. Yes. Yes. So this, when it's a negative exponent, it goes to the bottom. So it's 1 over t to the 2/3. And then we have to write it in radical form. So it's 1 over t squared inside a cube root. But can I have a radical in the denominator? So what are we going to do? How do I get rid of a radical? Yes, we're going to times by the missing factor. So this is a cube root, right? I have 2 t's right now, which means I need 1 more t. So I'm going to multiply by the cube root of t. Whatever I do to the bottom, I have to do to the top. That means I have the cube root of t over t. Logan, that's enough. Thank you. Try one more like this. Let's say I have y to the 2.5. So what's a better way to write this so we know how we're going to write it in radical form? 5/2. So this is y to the 5/2, which means I have y to the 5th power inside a square root. Is that done? I have 5 y's in there. How many groups of y's get to come out? So I have y squared square root y. All right. Go on to example number 3. I need you guys liven up. Logan, are you still with us?
Yeah.
Okay. Sample number 3 is going to cover 28 through 34. In this one, I want you to write it in exponential form. All right, so let's start off with something easy. Let's say I have the square root of, 15. That's really easy. How can I write that with an exponent on it? Correct, 15 to the 1/2. That is 15 to the first power inside a square root. So what if I had the cube root of x to the 5th? Yep, x to the 5/3. It is always the power over the root. Okay, so let's get one a little bit trickier. Let's say I have the 4th root of 7x squared. So underneath that fourth root or that radical, we have a group, which means if we have a group, we're going to use a grouping symbol. All right? So my grouping symbol is a parenthesis, 7x squared. Then I can raise this to the 4th power. Now, that's legit. We can use that today, or we can take that 4th power to both of them if we wanted to. I'm sorry, to the 1/4 power. My bad. I apologize. 1/4 power to the side of 4th root. So then we can distribute that 1/4 to both things. You can say 7 to the 1/4. And then x, if I multiply my exponents, I actually get 1/2, don't I? So which form shows me that I originally all started in a 4th root?
First one.
The first one, yep. Okay, but again, both answers are correct. How about one like this? What if I write it as the 5th root of a, and then I put my power on the outside? This is still power over root. Okay? So if I were to put 3 of these next to each other, I would multiply all my insides together anyway. So this is a to the power over root. All right, example number 4. Example number 4. This is going to cover your 36, and 38. Really is no big deal at all. They're going to give you this paragraph of stuff to read, and they give you h equals 0.00252 d to the 2.27 all over e. And then they're going to tell you what d and e equal. You just got to plug them in. So first they give you this equation. They tell you that d equals, let's say 100. And e equals 1.2. So you're going to grab your calculator and plug it in. 0.00252 times 100 to the 2.27 divided by 1.2. Hopefully, what'd you guys get? Good. Sounds good. 72.8. Technically, that's in meters, but so you have a couple of those where you're just plugging it into your calculator. All right. Last example, then, is going to cover your last couple. which is going to get you started into what we're learning tomorrow. So, example number 5. Let's say I have this is going to cover 40 and 42. Forgot that part. 40 and 42. And I want you to find the product. Let's say I have 7 inside a 7th root times by 7 inside a cube root. All right, so the other day we were doing these and I said that's not possible. Let's write it differently and see if we can make it possible. So the first one, I would rewrite this in exponential form as 7 to the 1/7 times by. This one, I could write as what? 7 to the 1/3, exactly. Okay. Now think about our exponential rules. Are our bases the same? Yes. So I can keep my base and add my exponents together. So that's going to give me 7. You got to get a common denominator. You grab your calculator and go math enter afterward. We should get 10 over 21, I'm hoping. All right, everybody's okay with what we just did? All right, so then that means since this started as a radical, my answer has to finish in radical form. This is 7 to the 10th power inside a 21st root. So now we can multiply them together. Oh, you guys look a little more thrilled than that. Okay, I'm done. I'll stop right there. Get a little excitement going. Something? Anything? No? Okay. All right, so we are doing problems 10 through 42 even. We're working with this whole rational exponent thing. Super excited about it.